Okay, so welcome back to this course. We're going to be talking about particle nature of matter and combined with crystal structures. Okay, so what is matter really? Matter is usually defined as anything that has mass and occupies space and do exist as solid, liquids, or gas. Okay, so that's the statement there. All right. So the atomic theory of matter assumes matter consists of tiny particles called atoms, which are always in motion. Okay, so basically anything we find on Earth that has mass, okay, and has the ability to occupy a space is referred to as matter. Manifestations are in solid form, liquid form, and gaseous form. So the atomic theory of matter assumes matter consists of tiny particles called atoms, which are always in motion. The fact these particles are always in motion means they have kinetic energy, which gives the theory an alternative name, the kinetic theory of matter. Okay? Now, this theory is based on certain experimental evidences, okay, which are firstly Brownian motion. Brownian motion is the irregular motion of particles in a field. Now, this was first named after the biologist Robert Brown in 1827. He observed pollen grains suspended in water and noticed even when the water appeared very still, the pollen grains still moved in an irregular manner. Its motion paths were zigzaggy, okay, which suggested they were colliding with some things which constantly caused a change in their direction, okay. And these things are said to be the moving water molecules, which are in constant rapid motion. This can also be seen in the movement of the zigzag movement of smoke particles in the air. Okay. Next, we have diffusion. Okay, diffusion is basically the process of migration of a particle or molecules from where they are in very high concentration to where their concentration is low. Okay, so the rate of diffusion, especially in gases, depend on density and temperature. Okay, so if a perfume is sprayed at one end of a room, in no time someone at the other end gets to perceive the perfume. All right, so that's the action of diffusion of molecules. So you have molecules diffusing from where they were sprayed, okay, where they're in high concentration, to places where they're in low concentration. So they spread out, they just spread, and you can feel the effect from the other side of the room, okay, considering the perfume we talked about. Okay, another thing to note is that diffusion takes place in solids, liquids, gases, okay, but they are really slow in solids. Okay, the rate of diffusion, especially in gases, depends on density and temperature. Okay, that has been said. Okay, so what is an atom really? Okay, so an atom is the smallest particle of an element that can exist alone, retaining the chemical properties of that element. Okay, that's very important. It can exist alone, yeah, but it has to be retaining the chemical properties of that element. If it's not retaining the chemical properties of that element, then it can't be an atom of that element. So let's say we have an element, hydrogen. You break it into a very small particle, the smallest particle ever, that can retain that property. That's if you go below that size, it will lose the chemical property and it will no longer be hydrogen. Okay, so that is an atom. All right, so an atom comprises of proton, neutrons, electrons. So you have the nucleus, okay, which contains the neutrons and the protons, okay, and you have electrons orbiting around them. Now these circular kind of lines that are drawn, okay, that are called orbits, are imaginary. They are not existing. You just have these elements, okay, you just have these electrons in space whirling round and about this nucleus. Okay, these lines are in no way in existence. They are imaginary lines drawn so you can see the path through which the electrons move. Okay, so our protons are positively charged. All right, our neutrons are neutral, our electrons are negatively charged. So these electrons are held in place by electrostatic attraction between them and the protons as they circle the nucleus in an orbit. The electrons are very light in weight, and this makes them easily transferable. All right, so molecules. A molecule is a group of two or more atoms joined chemically to form the smallest particle or fundamental unit of a chemical compound that can take part in a chemical reaction. Okay, so you have an atom, but you want that element to take part in a chemical reaction. Then the smallest particle that can take part in a chemical reaction is what you call molecule. A molecule can be made up of similar atoms or different atoms. Alright, so examples are, you have water. Water is made up of H2O. That's two atoms of hydrogen and one atom of oxygen. So we have water by that combination. Another one is nitrogen. Another one is NaCl. One atom of sodium, one atom of chlorine would give you table salt. So an oil film can be used to estimate the size of a molecule, and to calculate the thickness of the oil film, we use the formula volume over area, where D is our diameter in centimeter and V is our volume in centimeters cube. So area of the film, okay, would be pi D over 2 squared centimeter squared. Now we need to note these formulas. This is for thickness of a film. Okay, so it's more like, you know, when you spill an oil on a flat surface, it's going to form a film on that surface. So the thickness of that film, we can find that by volume over area. The area of the film now is to be found with pi D over 2 squared. Alright, so that's what we do to find that. So if we put this area in this first equation we have, we're going to have the thickness of the film as V over pi D over 2 all squared equal to, if we simplify this, we're going to have 4V all over pi D squared. Okay, I'm sure we know where this 4 comes from. This 2 is squared. Okay, and if you move it upwards, you have 4V all over pi D squared. Okay, so we have the matter exists in 3 states: solids, liquid, gases. For solids, they have a defined shape and volume. Okay, and this is because their molecules are closely packed and are rigidly held together. All right, their forces of cohesion is usually high, so you have their molecules held together. Okay, and these molecules have a fixed position and they can only vibrate about that position. Okay, so that's how solids are. While we have liquids, okay, they have really no defined shape. They take up the shape of their container. All right, the cohesive force or intermolecular force binding them are weaker than solids, so they are free to they're free. They could move around randomly within a confined space provided by a container. So normally they can take up the shape of their container. Okay, so you could place them in any kind of container, they'll just take up the shape of that container. All right, so for gases, their molecules are just really free to move about. Okay, they can move in any direction to any extent. Okay, if there's no container, they're just free. There's basically almost no intermolecular force or cohesive force binding them together, so they're just free to move about. Okay, so because of these facts, they don't have a fixed shape. Okay, they have no fixed volume, and you can actually compress them so easily because they don't have a fixed volume. So note that when solids are heated, their molecules acquire enough kinetic energy to overpower those intermolecular forces holding them bound. So because of that, their structure collapses. The structure will just collapse and liquids are formed. Okay, so when liquids are heated, okay, and their molecules also gain enough kinetic energy to break off the remaining intermolecular force binding them together, that cohesive force holding them bound, they can even escape from the liquid. All right, becoming gases in the process. They just jump off their liquids. Those molecules just jump off their liquids just like that, and then become gases. Okay, so that's basically it. Let's talk a little bit about crystal structure. So depending on the arrangement of atoms, solids are usually divided into crystalline and non-crystalline solids. Okay, another name for non-crystalline is amorphous. So a crystal is a solid matter that has a structure where atoms, molecules, or ions are in regular repeating arrangements called a lattice. So you can see this is a unit cell. Okay, this is a unit cell for a crystal, and that cell, you can see, makes up the lattice. So you have here about 1, 2, 3, 4, 5, 6, 7, 8, about 8 of them here making up a lattice. So you can see why it is said that the molecules are in a regular repeating arrangement. So this is a regular repeating arrangement of a unit cell, okay, called a lattice. So the smallest unit of the lattice is called the unit cell, which has been said here or described here, and can be defined as the smallest repeating unit having the full symmetry of the crystal structure. Okay, it has the full symmetry of the crystal structure. Okay, so there are three representations we have for the unit cell. Okay, that unit cell that makes up this lattice, there are three representations for them. We have the simple cubic representation. Okay, so in this one we have identical particles at each corner of the unit cell. Okay, so you know this is a unit structure, so you have one particle at one edge, one particle at one edge, and that particle at the next edge, just like that. So we have 8 particles, okay, at the different positions of this cube. All right, so this is the structure called simple cubic, and this structure now can build up to form a lattice. Okay, so we have another one which is the face centered. All right, now in this one you have identical particles at each corner, just like you had in simple cubic, but then you now have one additional one per face. So you see this face here has 1 at the center, this face here has 1 at the center. So we have 6 faces for the cube, right? And those 6 faces will have 1 particle at its center. Okay, so once you have this kind of structure for the unit cell, it's face centered, and this can build up to form a lattice. Okay, so we have another one which is body centered. So we have particles at every corner of the unit cell, but then we have just one at the center of the block. Okay, so we have 1 2 3 4 5 6 7 8 at the corners of the unit cell, but we have one that sits at the center of the block, inside the middle of the block. Okay, so that's what is called body centered. So we have examples of all this. You can see that this simple cubic is the structure for NaCl, which is the table salt we have. Okay, this is its structure. We have the face centered for stuff like copper, aluminum, metals of this kind. Okay, we also have the body centered for chromium. So amorphous means without a clearly defined shape or form. So as the name implies, amorphous substances lack regular arrangement of atoms and have no form. Okay, so due to its lack of order, they have unique properties. Okay, one of them is they don't have a defined melting point. All right, they have uniform mechanical strength, electrical and thermal conductivity. So examples of these amorphous substances, that's substances that have no structure, and they have no crystalline structure. Rubber, glass, we have these two as examples. Okay, so let's look at characteristics of amorphous substances. One, of course, first of all, they lack an ordered atomic structure. Okay, so what happens is they don't have a particular defined melting point. All right, they just soften when they're heated. All right, so that's why you can easily beat them into shape. You can easily get them to get different shapes once you heat them. Okay, another characteristic is their cooling. Okay, so once you cool them after heating them, they form supercooled liquids, not solids. Okay, they form supercooled liquid. We call them supercooled liquid, not solids. All right, this is the cooling curve for the crystalline substance, while this is the cooling curve for the non-crystalline substance. So we can see that for the crystalline substance, once it's at a very high temperature, at this point is most likely a gas, and you start cooling it down, it cools to a point and the temperature remains constant. Okay, so once you're cooling down, of course temperature falls and keeps falling as time goes, but it gets to a certain point where temperature stops falling and time just goes and it remains at the same temperature. At that point is the point where it changes state. Okay, so a change of state happens at that point and it stays there until the change of state is completed, and then it continues to drop again. Okay, so that's one major difference between the crystalline and non-crystalline. Why you see these ones? Okay, once you begin to cool them, they form supercooled liquids. All right, so that's the difference between the crystalline substances and the amorphous substances.